Welcome to Web Handling. My name is Dave Roysum. We have had many great questions rolling in from our recent Baggy Web series. Let me answer a couple of these here. By now you have seen a picture showing the web entering the winder flat, but having a thickness profile variation, yet leaving baggy after unwinding. The figure shown below is a reminder of what that model looked like. Also, in my Web 101 school and elsewhere, I talk about the work of Celia Land, myself, and many others giving a threshold of pain for diameter difference across a single roll. So, why then does bagginess sometimes appear as bad or even worse near the bottom of the row where there is no significant diameter variation accumulation? This is a great question showing that people are paying attention. The differential stretching model given is valid and easy to understand. What requires a bunch more background is the pressure distributions and combined stress. From my 2-day advanced winding school, or my winding book, you can see that while the stretching is worst at the top of the roll, the pressure is worst at the bottom. It is this combined stress that may take a material into yield. If it yields at the top, it is mostly due to extra stretching at the gauge band. If it yields at near the bottom, it is mostly due to extra pressure at the gauge band. If in the middle, a little of both. So, now you see that most of the messiness and why the simplest of the two mechanisms is the one people will likely to understand or remember, and the one that is taught most often. Still, in either case, the bagginess is at the gauge band, as it causes both extra stretching and extra pressure. The location of that band is most important for troubleshooting bagginess, not whether the problem is more severe at the top or the bottom. The same two general options exist whether at the top or the bottom. Loosen the wind, level the gauge variation. Loosening the wind is covered in great detail in my Web 101 class and elsewhere. The second question has much more of a practical implication. That is, why do we sometimes see bagginess coming off of shipping rolls, but not the parent rolls that made them? The answer is quite simple. Shipping rolls are necessarily wound tighter. This means that even if the parent rolls look good, that does not mean that the daughter rolls will be good. Bagginess, as well as any tight defects such as corrugation, starring, and so on, will be risky or much riskier on shipping rolls than parent rolls. In the case of bagginess, your customer will be the very first one to see it. In other words, bagginess is something of a hidden defect, as it may escape all but the most careful of wound roll measurements. Thank you so very much for watching this module in my Plant Practical video series. Keep the questions rolling in because it gives me inspiration for writing. Be sure to like and share. See you next time.